All right, guys, so today we're going to do notes for 514, which is sketching graphs of polynomial functions. And after today, you're going to be able to use zeros and multiplicities to sketch graphs of a polynomial. So first, it's an activity right here, activating strategy. And what do you notice or what do you wonder about the graph? Well, it has different graphs. One is quadratic, polynomial, kind of looks at it go in different direction. Well, what I can notice is that right here, it touches at zeros, which is our x-intercepts, and there's few of them. And if I count the zeros, it says that there is one, but up here it shows that I have two of the same numbers. Here it says that I have two places where it crosses an x-axis, but if I count it up, it looks like there's going to be a little bit more than two. What it's saying is that when you're looking visually on a graph, you able to, let's just see one x-intercept at 3, okay? Now here it looks like x is at -1, and here x is at 3 again. Here it looks like it's at 3, and x is at 6, and here it looks like it's at 3. Well, different shapes of a different graphs will indicate a different multiplicity. And what does that mean, a word multiplicity? Multiplicity means that sometimes when I think there's only one x-intercept or 1, 0 at the point, that might not be the truth. There might be more than one at the same dot, okay? Now, how do I know that? Well, there's a rule where if the shape looks like a function is crossing, like slicing through x-axis, like a slice, that would mean to me that there is a multiplicity of 1. Okay, so what does it mean? That means that on this dot right here, there's only 1, 0, one x-intercepts at this point, and it is at x equals -1. Okay, now when the function looks like it is bouncing, so more like this or like this, okay, oopsie, wrong one, I'm sorry. Right here, guys, like this, it's bouncing. So it touches the x-axis, but it does not cross. This is called a bounce. Okay, when it bounces, that means that there is two or more even points in there. So the multiplicity is 2. Okay, so that means there could be 2 or more even zeros and x-intercepts. So that means this also indicates there's 2. That means that at the same point, there's 2 the same numbers. Here at the same point, there's 2 the same numbers. Here at the same point, there's 2 the same numbers. So this was 3. There's another one that's 3, okay? Now, this one right here, so here it's something called a slide. This is where the function goes on, slides on the graph, and then crosses the x-axis. Okay, that's called a slide, and this is a multiplicity of 3. Okay, so that means inside here, that could be 3, the same answers at the same point right here. Okay, 3 or odd. So you could have this is x equals 3 times. Okay, or it could be 7 times and so on. It would be an odd number. All right, so just keep that in mind. So you got a slice when it crosses like an ox, like one time. Okay, you got a bounce when it touches the x-axis and bounces up, and then slides when it crosses it by sliding it. So here it just says that for the given zeros, if the multiplicity is odd, so odd number like a 3, 7, 11, the function would be crosses x-axis, okay? Now, if for given zeros the multiplicity is even, that just means that it's going to be bouncing. So it will touch it like this, and it will never, ever cross it, okay? All right, so now when we talk about polynomial functions and finding their zeros and multiplicity, they are going to be represented in a factor form, like this right here. Okay, we learned factor form when we did quadratics. So that means if we want to find our zeros, means our x-intercepts, we're going to equal each of these factors to a zero, which is going to give us the opposite sign. Okay? So I equal each of these parentheses to 0, and I got a opposite sign, okay? Now, these are my zeros, and I am going to graph them right here. So this is at -9, this is going to be at -3, and this is going to be at +4, okay? Now, those are facts that I know. Now, in this parentheses, I have a little 2 here, and then I don't have anything here, and I don't have anything here. Well, remember that when there is nothing there, that means there is a 1, okay? And then, of course, I got a 2 here, okay? So what does that mean? That means that there is one of these answers of -9, one of the zeros of -3, but there's 2 of the zeros. There are 4, so there's 2 of them, okay? What is also does it mean? So now let me see if I can graph it. Remember that slice represented 1 multiplicity of 1. Let's just put it this way. So slice was multiplicity of 1. Bounce was multiplicity of 2. And slide was multiplicity of 3. Okay? Now, so if I see that there is a 2 here, that means this is going to be a bounce. If I see if there's 1 there, this is going to be a slice, and I see there's 1 there, this is going to be slice. So this is going to be for a graphing purposes. Now, I'm going to try to graph it, but which way do I start and where do I go? Well, I am going to start with my leading coefficient. Do we remember what leading coefficient is? Well, leading coefficient is the number and the sign that leads the equation. So right here, I have a +1 there. It's not written, but it's assumed to be a +1. If I have a leading coefficient that is positive, that tells me that my ant tail, it's going to end up going up at the end. Okay, that's what I know from looking at this equation. So I'm going to start going backwards from the end. Now, if I start going up, if I want to go backwards, I know that at 4, there is going to be a bounce. So I'm going to go down. Let me fix it up to make it nicer. Okay. Now, this is my leading coefficient. This is going to bounce right here. Okay. Now, I also know that I'm going to slice through -3, and I'm going to slice through -9. Okay. So again, this is a slice because the multiplicity, it's 1 and 1, and there is a bounce because the multiplicity is 2. Okay. So that's how we determine how we're going to graph it. Now, I also know that my leading coefficient was positive, so my ant tail right here was going up. I also know that I can read what is the degree of this function. Well, the degree of the function is the same as their multiplicity. So since I have a multiplicity of 1, 1, and 2 together, it makes it a 4. So this is a 4th degree function. Okay. Now, what does that also mean if I say it's a 4th degree function? It means the function is even, which tells me that both ends of the function will be going up. Okay. Now, when I talk about end behavior, I have a left side and a right side of the function. So positive, x is going toward positive or negative infinity. Okay. Now, this is positive and this is negative. Now, I know that both of my ends are going to go up regardless. So that means my function will be going up, and here the same because this is an even function in direction. All right. So again, if you need to pause it, please pause it or write it down because I'm going to switch. All right. So for this example right here, the same thing. Okay, we're going to find our zeros first. So I'm going to equal them to 0. So this is -2, and this is going to be 2. Okay, so you're going to have -2 right here, and these are your 2 zeros. Now, I can tell that there's a 1 multiplicity here and 2 here. That means I'm going to have another answer here. Okay, so this is going to be a bounce, and this is going to be a slice. Now, I'm going to start with the leading coefficient, which is -1/2. Okay, that means my leading coefficient is negative, which means that my tail would be going down. Okay, and I'm going to backtrack it, and I know that at 2, I'm going to bounce it. So I'm going to go, touch it, and go back down. And then at -2, I'm going to slice it. Okay, so here I am slicing, here I am bouncing. All right, so now I can also find what's the degree of my function by counting the multiplicities, because it's going to match. So I got a 1 and a 2, so the degree is 3. Okay, it's the third degree. Now here again, my zeros were x equals 2, and their multiplicity was 2. And x equals -2, and the multiplicity was 1. If you want to go back here, if you want to write it out, because I missed that right here. Again, my zeros means my x-intercepts. You had x equals -9, and the multiplicity was 1. You had x equals -3, and the multiplicity was 1. And you had x equals 4, and the multiplicity was 2. Okay? All right, and then again, this is a third degree function, which means it's an odd function, which means the ends are going to go in the opposite direction. So that means when I'm on the right side or the left side of the graph, okay, my ends are going to go in the opposite direction. On the positive side, my function travels down. And on a negative side, okay, my function travels up. So I'm going to write that out here. Okay. Again, if you need to pause it, please do so. All right, now we're going to try to figure out how can we go from the graph to a factor equation of the polynomials, a polynomial equation in a factor form. Well, again, this is right here. It states that x equals -a, and this is x equals b. Now, to get it back to a factor form, we got to move it to the other side. So x plus 8 equals 0, and x minus b equals 0. Now, my two factors are x plus a and x minus b. Now, I'm going to try to figure out the multiplicity by the shape. So this is a bounce for a b. It's going to be a 2, and this is a slice for an a. It's going to be a 1. Okay? Now, I also need to pay attention to a negative leading coefficient, okay, which means there should be a negative in the front. Positive, you need to write it down. All right, now again, I'm going to find my zeros right here, okay? So the x-intercepts that I see right here are x at -3, x at 2, and x at 5. Now, if I want to, again, put it into a factor form, this is going to be x plus 3, this is going to be x minus 2, and this is going to be x minus 5, okay? Now, what is the multiplicity? Well, right here I have a slice. So at -3, it's a multiplicity of 1 because that's a slice. Okay, at 2, it's a bounce. So that's a multiplicity of 2. Okay, and at 5, it's a slice again. So that's a multiplicity of 1. Okay, now I can put it into and use these factors right here to put it into a factor form. Okay. So, and then I can also add the multiplicity of a 1, 2, and a 1. All right, and this is just a ticket out the door, guys. So it gives you a few key factors about the equation. It tells you the end behavior, the degree, and a 0. So I'm going to start with the 0. So I'm going to graph it right here. It tells you that my zeros are -3, a 4, and a 6, okay? Now, it tells me this is a 4th degree. That means I should have 4 zeros. That means that one of the zeros must be double. That means it must be a bounce, okay? So It doesn't say which one, so I can kind of pick. And then it also tells you that when x's get larger and larger in either positive or negative directions, it means as long as I go to the left or right, the g of x, which is my function, gets negative direction. So that means it tells me that both ends will go down. Now, I cannot, it doesn't give me any more information to say, okay, 6 is going to be a bounce, so 4 is going to be a bounce, and -3. So I can write this in 3 different options. This can be a bounce, and then this can be a slice, and this can be a slice. Okay. The bottom line is both ends go in the same direction. And this makes it 4 zeros because I have 1 here, okay, 1 here, and then 2 here. Okay, so that makes it a 4th degree. I can write another function where, again, this is -3, this is 4, this is 6. And again, I can make the 6 a slice, and then a 4 a bounce, and then a 3 a slice. So again, here I had 6 as a bounce. Here I have 4 as a bounce. And then again, lastly, I can do a last one, and it's going to have -3, and then 4 and a 6. And what I can do is I can make a 3 a bounce. So it comes from the bottom because it's a negative leading coefficient, and then positive, and then here it will bounce, okay? So again, this would be a bounce here, and a slice, which makes it 4th degree, and both ends go toward the bottom because it's a negative leading coefficient.